In this video, we are going to learn about unit and measurements. So we'll be looking at fundamental and derived quantities in physics. So let's begin with fundamental quantities. So what are fundamental quantities? They are simply those quantities in physics in which other quantities depend on. Alright, so we have basically about 7 of them. So let's begin with mass. Alright, so mass is a fundamental quantity and the unit of mass is kilogram. That is measured in kilogram. Short form is kg. We also have our length. The unit of length is meter. Short form is m. We also have our time. The unit of time is seconds. Short form is x. We also have our temperature. The unit of temperature is Kelvin. Short form is K. Alright, we also have our electric current. The unit of electric current is ampere. Short form is A. Alright, we also have our amounts of substance. Amounts of substance. The unit of amount of substance is mole. Short form is mol. Okay, we also have our luminous intensity. So the unit of luminous intensity is candela. Short form is CT. Alright, so these are the 7 fundamental quantities we have in physics. Now note that all these quantities here are scalar quantities. As we all know, in physics, scalar quantities are those quantities in physics that have magnitude but no direction. So all the fundamental quantities here are scalar quantities. Alright, so having known this, let's wipe this now. Look at derived quantities. Okay, so what are derived quantities? Derived quantities in physics are those quantities that are gotten by simple combination of 2 or more fundamental quantities. So when you add 2 or more fundamental quantities, it will yield or give you a derived quantity. So let's look at a couple of them. We have area. Area is one of them. So as you know, to calculate area is calculated using length times breadth. Okay, and its unit is meter square. We also have volume. Volume is calculated using length times breadth times height, and its unit is meter cube. We also have density. Density is calculated using mass over volume. So the unit of density is kilogram per meter cube. Right, so we also have our speed. So speed is calculated using distance over time. So this is n, distance by time, and the unit of speed is meter per second. Alright, so we also have our velocity. So velocity is calculated using displacement over time. Displacement over time, and it had the same unit with speed, meter per second. Now the difference between speed and velocity is that speed is a scalar quantity, whereas velocity is a vector quantity. Speed has magnitude but no direction, but velocity has both magnitude and what? Direction. Right, so we also have acceleration, which is calculated using velocity over time. Alright, so the unit of acceleration is meter per seconds square. Okay, we also have our force. So force is calculated using mass times acceleration, and the unit of force is Newton. So the short form is N. Okay, we also have our weight. Now, weight is calculated using mass times acceleration into gravity g, and its unit is also measured in Newton. And short form. Alright. The difference between weight and mass is that mass is a scalar quantity, whereas weight is a vector quantity. Alright, so that's just the major difference between weight and mass. Alright, so let's look at another example of a derived quantity. Okay, we also have our momentum, which is calculated using mass times velocity. Alright, so the unit of momentum is Newton second. The unit of momentum can also be kilogram meter per second. So any of these can serve as the units of momentum. Alright, we also have our pressure. Pressure is calculated using force over area, and the unit of pressure is Pascal. Alright, so you can also have other units, but the common unit is Pascal. Okay, so let's wipe this and look at a few more examples. Okay, so we also have work, which is calculated using, so work is calculated using force times distance, and its unit is joules. Short form is. We also have energy. Alright, energy, there are various ways you can calculate energy. We have kinetic energy, we have potential energy. Alright, MGH, you can calculate energy using MGH. You can also calculate using half mv square. Alright, depending on the type of energy you are dealing with, and its unit is also joules. Energy is also measured in joules. Okay, now it can also, it depends, you can also calculate energy using force times distance, depending on the situation you have. Alright, so energy is a derived quantity. The difference between energy and work is that energy is a scalar quantity, whereas work is a vector quantity. Energy has magnitude but no direction. Work has both magnitude and direction. Okay, we also have our power. So power is calculated using work over time, and is measured in watts. Alright, so we also have our impulse. So impulse is calculated using force times time. Okay, so the unit of impulse is Newton second. We can also measure impulse in kilogram meter per second. So anyone will work. Okay, so these are the basic derived quantities we have in physics. We have others, but these are the basic ones. Alright, so with this we have come to the end of the class. Now know that you should get yourself familiarized with these various quantities and their units, because they are very important. It will help you in the discipline of physics in the long run. Get yourself used to them if you want to be a good physics student. Alright, so that's for this class. Thanks for watching. Hope you learned something interesting. In this video, we are going to learn how to find dimension of physical quantities in physics. Alright, so ensure you stay to the very end of this video. I'm going to simplify everything. Okay, so it's important to note that the essence of dimension of physical quantities is to show how a derived quantity can relate to the fundamental quantities of mass, length, and time. Alright, so having known this, let's look at examples. What if we are asked to find the dimension of velocity? So how do you go about it? As we all know, velocity is calculated using displacement over time. Alright, now when you talk about displacement, you're talking about the length of something, right? That means it will be measured using length, whereas the time will remain the same, since you're looking at how this derived quantity will relate to these parameters we have here. So this will be the dimension of velocity. It's either you leave it this way or you leave it like this, length per time. It's mostly like this. Alright, so this is the dimension of velocity. Now let's look at another example. What if we are asked to find the dimension of acceleration? Okay, acceleration is calculated using velocity over time. Now, and you know, velocity is over time, and we know that when we talk about distance, we're talking about length, right? Length this time around, we now have 2 time in this expression. That means length over t square, and this will be the dimension of acceleration. Let's leave it like this. This is how it is normally expressed. We not normally leave it in this format. They leave it in this format, length per time square. So this is the dimension of acceleration. Alright, so what if we ask to find dimension of force? What would be the dimension? So force is calculated using mass times acceleration. Alright, since mass is relating to this, the mass will remain the same. So we have mass times acceleration. Dimension of acceleration here, we have it to be length per time square. Alright, so this dimension of acceleration. So when you add everything together, we're going to have dimension of force to be mass times length times per time square. Alright, this is 2. This is dimension of force. Alright, so let's write this and solve another example. What if you're asked to find the dimension of momentum? Alright, so momentum is calculated using mass times velocity. That means, remember, we are looking at how these derived quantity relate to mass, length, and time. That means mass will not change because mass is relating to this. So we have it to be mass times the dimension of velocity. We had it to be, this is velocity equals displacement over time, which will be length over time. That length per time. So it will be mass times length per time. So when you bring everything together, it will be mass times length per time. And this is the dimension of what? Momentum. Alright, so what if we are asked to find the dimension of density? What is it going to be? Density is calculated using mass over volume. So mass remain the same. Volume is the length cube. Volume is length times breadth times height. So everything here is talking about length. That's why we have 3 lengths there. That's why we have length cube. So when you express it this way, it's going to be mass per length cube. So this will be the dimension of density. Let's write this and solve another example. Okay, what if you ask to find dimension of pressure? Right, pressure is calculated using force over area. Alright, and force is mass times acceleration. Force is mass times acceleration, right, over area. Now remember, we got the dimension of force to be mass times length times per time square. Let me show you. Force equals to mass. Mass will not change. Since mass is related to m, we have mlt. So mass is related to m here out of the l and t. So mass is related to the m here. Alright, then mass will not change, and acceleration is velocity over time, and velocity is talking about displacement over time. So we have 2 time here, right? And these v and d are talking about length. So we have length per time square. That's how we got this. Alright, so don't be confused. So the dimension of force is mass times length times per time square. Alright, over area is talking about length times breadth. Right, that's how you calculate area. Length times breadth. Okay, that means we have 2 lengths here. So dimension is length square. That will be the dimension. Alright, so we have mass times length per time square over length square. Alright, so when you do the applying the CC, NDC states that when you're having 2 bases that are the same, like L is here, so they're the same, and they're dividing each other. When the law of indices, you subtract their power. So this is going to give us mass times length 1 minus 2 times per time square. Alright, so when you simplify, you're going to have mass times per length times per time square. Alright, this is per length, and this is the dimension of pressure. So let's show one more example, and after we can call it a class. Or if you are asked to find dimension of power, alright, as we know, the power is calculated using work over time. Alright, and work can be calculated using force times distance over time. Alright, now dimension of force, we have it to be mass times length times per time square, then times this distance here is talking about length, this distance here talking about length, then over time. Alright, so we are going to have, when we simplify this, we're going to have mass times length square, this length times in this length, we have length square, then times per times square, alright, minus 1, because the base is have time and time here, so they are dividing each other, subtract the power. So when you simplify this the more, you're going to have the dimension of power to be mass times length square times per time cube, and this is the dimension of power. So guys, this is basically how you can solve problems or find the dimension of physical quantities in physics. I hope that's something interesting. And with this, we have come to the end of this class. In this video, we're going to look at the concept of vector in physics. We look at unit vectors in either 2 or 3 dimensions. Alright, so let's begin with the basic definition of vector in physics. So vector is simply a quantity that has both magnitude and direction. Alright, for instance, velocity is a vector quantity. So a body can have a magnitude of 20 meters per second in a particular direction, maybe east, west, north, or south, as the case may be. Alright, so we also have impulse. Impulse is a vector quantity. We also have acceleration, we have momentum, we have work done, we have also weight. Yes, weight is the vector quantity, and we have our field forces, that's the electrical force, the magnetic force, and gravitational force. So these are examples of field forces. They are all vector quantities in physics. Alright, so they have magnitude and direction. Now, whereas scalar quantities are those that don't have direction but they have only magnitude. Alright, so example of fundamental quantities are scalar quantity. Example, we have mass, time, we have our length, our electric current, temperature, even energy here is a scalar quantity. We also have power. Power is a scalar quantity, and the rest of them. So be sure to know how to differentiate a vector quantity from a scalar quantity. Alright, so let's write this now. Look at unit vectors in 2 or 3 dimensions. Alright, so let's look at this question. It says if vector p equals this value and vector q equals this value, find I the magnitude of vector p and q, I the scalar product of p and q, and I the cosine of angle between p and q. Okay, so the magnitude of the vectors will be, this is how we present it, as if we are finding the absolute value of a number or of a function. So it will be the magnitude of p equals square roots of the square of the ijk value. So it's going to be the magnitude of vector p would be square root of 7 square, right, plus bracket minus 3 square, right, plus 2 square. Right, okay, so let's put everything in brackets. Right, so when you simplify this, you're going to have square roots of, okay, 7 square will give us 49, alright, minus 3 square will give us 9 plus 9, alright, 2 square will give us 4. So when you simplify, we're going to have square root of 62. So when you break this down, square root of 62 will give us, let me punch it here, it's going to give us 7.87. Alright, so let's leave it in 2 decimal places. So this will be the magnitude of this vector P. So let's write this now, solve for the magnitude of vector Q. Okay, so the magnitude of vector Q will be, so square root of, we have 4, put the bracket square, alright, plus 5 square, alright, plus in bracket minus 3 square. So if you simplify, you're going to have square root of 4 square is 16, plus 5 square is 25, alright, plus minus 9, minus 3 square rather is 9, alright. So when you simplify, you're going to have square root of 50. So if we break this down, it's going to give us 7.07. Alright, so this will be the magnitude of vector Q. So it's as simple as that, guys. Now let's write this and solve for the scalar products. Okay, so the scalar products will be the sum of the product of the similar vectors. So that's the dot product of between P and Q will be, we have 7 times 4 plus minus 3 times 5. So we put it in bracket because of this negative 3, alright, plus 2 times minus 3, put it in bracket because of the negative 3. So when you simplify, we're going to have 7 times 4, we have 28, minus 3 times 5 will give us minus 15, so minus 15 times this will give us minus 15, still minus 15, alright. Then 2 times negative 3 will give us minus 6, minus 6 times this plus here still give us minus 6. So when you simplify further, we're going to get 7 as the answer. So this will be the scalar product of these vectors P and Q. Alright, so let's wipe it and solve the last question, which is the cosine of the angle between P and Q. Alright, so the cosine of the angle between vector P and Q will be cos theta equals the scalar product, that's dot product between P and Q over the magnitude of vector P and times the magnitude of vector Q. Alright, so this is Q. So remember the magnitude of vector P, when we did it, we got it to be 7.87. That of vector Q, we got it to be 7.07. Alright, so when you substitute the values, they're going to have cos theta because the scalar product is 7 over 7.87 times 7.07. So when you simplify this, then punch my calculator is going to give me, so I have it to be 0.125 if you are leaving it in 3 decimal places. Alright, so we have, remember we have cos theta equals the 0.125. So to make theta the standard formula, divide both sides by cos. So this can, therefore theta will be cos inverse of 0.125. Alright, so let me punch my calculator. Okay, so cos inverse of 0.125 will give us 82.81 if we are leaving it in 2 decimal places, and this will be the cosine of the angle between vector P and Q. So guys, this is basically the concept behind unit vectors in 2 or 3 dimensions. This one we use, for example, is vectors in 3 dimensions. Alright, so the same approach is applied to the one that involves 2-dimensional vector and others. So with this, we have come to the end of the class. Hope you guys have something interesting. In this video, we are going to look at the equations of motion in physics, how to apply them in solving questions under motion. Alright, so let's begin with the first one. So basically there are 4 of them. The first one, we have V equals U plus AT. We have the second one to be X equals UT plus half AT square. We have the third one to be V square equals U square plus 2AS. Alright, we have our X equals V plus U over 2 in brackets t. Alright, so here our v is our final velocity, our x is our distance. Let me write it here for you. Our v is final velocity. Alright, our u is initial velocity. Then we have the t is time, the x is distance. Alright, so these equations are very important in motion under physics. So most of the problems will be solving in motion. You will need the knowledge of these equations to solve them. Correct. Alright, so very important to get used to these formulas. Now note again that motion under gravity, this equation, the acceleration here we change to acceleration due to gravity. For instance, well, let me wipe this place. If you are dealing with motion under gravity, the v will be u plus gt. Now the x will be ut plus half gt square. The v square will equals u square plus 2gx, and in that order. This fourth one does not have acceleration in it. So when you are dealing with motion under gravity, the acceleration A will change to acceleration due to gravity G. Alright. Now this equation is when the motion is with gravity, is responding to gravity. When the motion is, for instance, when a body is falling down or when an object is thrown down, so is responding to gravity. But when an object is thrown up or something is moving up, it's going against gravity. The equation of motion will be u minus gt, because this minus signifies that it's going against gravity. Same is applicable to ut minus half gt square, and v square equals u square minus 2gs. Alright, so take note of this variation. This one is responding to gravity, this one is going against gravity. Right, so let's look at a couple of problems here and solve them together so that you understand how to apply these equations to any question, any problem you are dealing with. Let's wipe this. Okay, so let's solve this problem together. It says a car moves from rest with acceleration 0.2 meter per second square. Find its velocity when it has moved a distance of 50 meters. Alright, so let's begin by getting our parameters. Okay, so in this question, our initial velocity will be, since it said the car moves from rest, right? From rest means that the initial velocity will be 0. Alright, since it's at rest, nothing is happening, so the initial velocity will be 0. Okay, then our A, we have our acceleration to be 0.2 meter per second square. Alright, then we don't have our V, final velocity, and this question does not have time. Does it have time? Find its velocity when it has moved a distance. Okay, you have distance to be 50 meters, does not have time. That means out of the three equations of motion, the one that will be suitable to solve this problem will be v square equals u square plus 2as. Alright, since we don't have time in this question, so when you substitute this value we have, you're going to have v square equals 0 square plus 2 times acceleration is 0.2 times 50. Alright, so v square equals 0 square is 0 plus, so let me multiply everything here with my calculator. Okay, so everything will give me 20. Alright, so we now have v square equals 20. So to make v the subject formula, you square both sides, so cancel the square root, so this square will cancel the square, therefore our v will be square root of 20, which will be, let me punch it, so we have it to be 4.47. We are talking about, okay, velocity meter per second. Alright, since if we leave it to do this math places, so this will be the answer to this question. Let's wipe this and look at a technical question. Okay, this question here says a ball is released from height of 20 meters. Calculate how the time it takes to fall. the velocity with which it hits the ground. Alright, so since the ball is released from a height, that means this is a motion under gravity. Let's bring our parameters. For in this case, we have our x distance to be 20 meter, and we are looking for time first. We don't know time, and we don't know. Okay, we have our initial velocity is going to be 0, so u will be 0. Let me explain. Okay, let's say this is a wall, this is a tall wall, and somebody is standing here and releases a ball. Alright, so somebody release the ball from this height. So initially, the ball will attain a initial velocity of 0, alright, before it starts making movements or falling. Hope you understand. So whereas the final velocity is unknown, so the velocity it will take from here till when it hits the ground here will be the final velocity. This one is our initial velocity, u, which is 0. So having gotten these parameters, now which equation are we going to apply? Remember, this is a motion under gravity. So we have these terms, we have time, we have u, don't have v. That means we're going to apply s equals ut plus, okay, is responding to gravity because it's falling, right? Plus half gt square. Alright, since the ball is falling, it's not going up, it's going down, is responding to gravity. Now, when you substitute this value, we're going to have our x distance is 20 equals 0 times t plus half. That means acceleration due to gravity, g is constant, which is 10 meter per second square. Alright, so when you impute it, you're going to have half times 10 times t square. So when you simplify this, you're going to have 20 equals, everything here will give you 0 plus 10 t square. Alright, so when you simplify it more, if you cross multiply, you're going to have 20 times 2, 40 equals 10 t square. So divide both sides by 10. This will cancel this. 10 t are 4. Then have t square equals 4. To make t the solid formula, you square both sides. This square can't be squared. Therefore, root of 4 is to therefore our time t equals to 2 seconds. Alright, so this will be the time. Now, let's wipe this and solve for the second way, the velocity with which it hits the ground. Okay, so we now know our t is 2 seconds. Now to get the v, final velocity, we can either use v equals to u plus gt, alright, or you can use x equals v plus u over 2 times time. Anyone will work, but let's use this one first. So to find v will be initial velocity is 0 plus our g is 10, then times our time is 2. Therefore, v will be, final velocity will be 20 meter per second. Whereas if you use this one, so our x is 20 equals our v is unknown plus u is 0, alright, over 2. The time is 2. Alright, so when you simplify this, you are going to have 20 equals 2v. 2 times 0 is still give you 0, so it's as nothing is there, alright, over 2. You can't multiply, so you're going to have 40 equals 2v. To make v the solid formula, divide both sides by 2. Alright, therefore 40 divided to 20, therefore v equals 20 meter per second, and velocity. So anyone will work, guys. Right, so it's as simple as that. Now let's solve one more example under this before I call it a class. Okay, look at this question. It says a ball is thrown up vertically with a velocity of 40 meters per second. Calculate A, the maximum height, B, the time to reach maximum height. Alright, solution. Remember, this is a motion under gravity under gravity, right? Yeah, because look at the ball is thrown up. Now it's going against gravity because it's not falling, it's going up. Remember what I told initially when I was starting this video. Okay, now since it's going against gravity, that means our G will be negative. Alright, so let's write that our parameters. Our initial velocity is 40 meter per second. Alright, then our G will be 10 meter per second square. Alright, remember G will be negative, not be positive. Whereas our, what else do we have? We're looking for maximum height. That's, we're looking for X is unknown. Alright, then our V will be 0. Let me show you. Let me say this is a wall and this is the ground. So when you throw up an object, let's say a ball, this is a ball. Alright, you threw up a ball. Now they say that this question says that the velocity you use to throw up the ball vertically is 40 meter per second. Okay, now the final velocity V will be the velocity at this maximum height. Let's assume this is the maximum height this ball reached when you threw it up. Alright, now this will be the maximum height, and this will be final velocity 0, because the ball will get to this point before it starts falling back again, before it starts responding to gravity. But this time around it's going against gravity, so it's reached this point. This point is reached before it began to fall back. This is the final velocity, but before it started to fall back. Alright, so the V will be 0. So let's look at the equation of motion we're going to apply to solve this. To get this distance, the maximum height, that's the distance. So it's going to be, we use V square equals U square. It's not plus, it's going to be minus because we're going against gravity, minus 2gx. Alright, so our final velocity is 0. Initial velocity is 40 square minus 2 times, alright, 10 times x. Okay, so when you substitute this in this, when you simplify this the more, you're going to have 0 equals 40 square will give us 1600 minus 20x. So to make x, which is the distance, is the formula. This 1600 equals over this equal this. I'm going to be minus 1600 equals minus 20x. Right, so you divide both sides by minus 20. So this will cancel the dynamic. Therefore, our x will be, when this divide this, we're going to have 80. Our x will be 80 meter. Alright, so this will be the distance, the maximum height distance. Right, now to calculate the time, very simple. Let's write this. So remember, now our x will be 80 meter. To calculate the time, we can use v equals to u plus, v equals u minus gt. Okay, so when you substitute, you're going to have our v is 0, equals 40, alright, minus g is 10, alright, t. Now, you make t the solid formula. This 40 equals to be minus 40 equals minus 10t. Divide both sides by minus 10, minus 10. Therefore, our t will be 4 seconds. So this will be the answer for this question. Now, this particular question can also be solved using projectile formula to solve it, because it's talking about maximum height and time to reach maximum height. So let's solve it projectile. Alright, let me show you how you can also do the projectile. Alright, in projectile, to calculate maximum height, you use u square sine square theta over 2g. So our u is 40. That's 40 square. Then this sine squared, that means you should times sine theta into 2 times. That you do sine theta times sine theta, that's multiplication to 2 times. Alright, now our theta will be 90 degrees. Let me show you, because this is the wall. When you throw up a ball from up, this is the ground, and making a connection with the ground, so you have form angle 90 degrees. So theta will be 90. Alright, so it will be sine 90 degree times sine 90 degrees, right, over 2 times 10. Because acceleration due to gravity, g is constant, p is 10. So when you simplify this, sine 90 is 1. This is the same thing as 40 square, which will give us 1600 over 2 times 10, give it 20. So we cancel this. 2 cancel itself, 1, 2 cancel, you're going to get 80. So you can see that you still get the same value for maximum height to be 80 meter. Alright, now the same thing is applicable to time to reach maximum height, which is, let me write this. Time to reach maximum height in projectile is calculated using u sine theta over g. Alright, so our u is 40, and 40 times sine 90 degree over 10. Alright, so sine 90 is 1, so we're going to have 40 over 10. So you still get back to 4 seconds. So either one will work for this particular question. Alright, so this is basically you can apply the equations of motion to problems involving motion and solve them. Alright, so guys, with this we have come to the end of the class. I hope we learned something interesting. In this video, we're going to look at the concept of projectile. Now let's begin with the basic definition of projectile in physics. Now, projectile in physics simply refers to an object or a body launched into space or thrown into space and moves freely by itself under the influence of gravity and air resistance. Okay, so let me illustrate the concept of projectile using this diagram. Let's say we have this diagram. Okay, let's say a missile is launched from this point. So the missile will make this parabola movement. Right? Now, this point where the missile was launched till this point it reached before it started to fall is known as the maximum height. So this is the maximum height. Alright, whereas from this point where the missile got projected till this place it fell, the horizontal distance is known as the range. Alright, whereas the time it took the missile to move from this place to this place is known as a time of flight. Now, time of flight in projectile is calculated using 2u sine theta over g, whereas maximum height is calculated using u square sine square theta over 2g. Range is calculated using u square sine 2 theta over g. Alright, now the time it takes the body to reach maximum height is calculated using u sine theta over g. Alright, now this movement it's made here, we call it parabola movement. This movement is not a parabola movement. in projectile, so we call it parabola movement. Alright, now so it's important you get yourself used to this formula because they will help you a lot in the calculations involving projectile, because when you miss one or when you don't know anyone, it might affect you a lot. So it's important you familiarize yourself with them, get used to it, and you'll be good to go. Alright, so let's wipe this now and look at some calculations on this. Okay, so we have this problem. It says an arrow is shot into the air with an initial velocity of 100 meters per second at an elevation of 60 degrees. Find time of flight, maximum height, and range. Alright, so let's begin with time of flight. Time of flight equals 2u sine theta over g. And in this question, our u, initial velocity, we have it to be 100 meters per second. We have our g, acceleration due to gravity, to be, it is a constant, right, meter per second square, and we have our theta to be 60 degrees. So if you substitute the values, you're going to have 2 times 100 times sine 60 degrees over 10. So let me punch this to my calculator and get the answer. Okay, so I have it to be 17.32. If you are leaving it in 2 decimal places seconds, so this will be the time of flight. Alright, so let's wipe this and solve for maximum height. Alright, for maximum height, the formula for it is u square sine square theta over 2g. So we have our u, g, and theta at there. So if you substitute them, we're going to have 100 square times. Now this sine square theta means you should multiply sine theta into 2 times. Alright, so you should multiply sine theta 2 times. Going to be times sine theta is 60 times sine 60. Right, so this is 0 over 2 times 10. So let me simplify this. Once you store it in your calculator, so I have it to be 375. So you're talking about height, we need to be meter. This will be the maximum height. So let's wipe this and solve for range. Okay, so range is calculated using u square sine 2 theta over g. So when you substitute, you're going to have 100 square times sine 2 theta is 60 over g, which is 10. So when you simplify, you're going to have 100 square times sine 2 times 60 is 120 over 10. So let me point this with my calculator straight and get the answer. Okay, so I have it to be 866.02. If you're talking about horizontal distance, range is horizontal distance. We're going to be measured in the unit will be meter. Alright, so guys, this is how you can solve this particular problem here. Let's solve one more problem, and after you can call it a class. Okay, so the question says a ball thrown up vertically with a velocity of 40 meters per second. What is the time taken to reach the ground? Alright, that's time of flight. Now, in this question, we have our u to be 40, initial velocity to be 40 meters per second, and we have our g, acceleration due to gravity, which is constant, 10 meters per second square. We now have our theta, and we're going to apply this formula u sine 2u sine theta over g. Now to get this theta, this is simple logic. Now look how we're going to, let me tell you, the theta will be 90. Let me show you. Let's say somebody is standing beside this wall, and the person standing beside this wall throws an object according to this question. Now throws the ball vertically. Let's say the ball goes up like this. This is the ball vertically. Now as the ball is going up you, the individual that is standing beside this wall, have already made a connection with the ground. This is the ground, right? We are standing on the ground. You made a connection with the ground. Now, looking at this, you can see that you have already formed angle 90 degrees as you threw up the ball vertically. Alright, so our theta will be 90 degrees. Okay, now, so the time of flight will be substitute 2u, that's 2 times 40 times sine 90 over 10. Alright, so when you simplify this, you're going to have, this is something as 2 times 40, sine 90 is 1 if you punch it with a calculator, over 10, which is 80 over 10. If you cancel that, therefore our time of flight to reach the ground will be 8 seconds. Alright, so this is basically how you can solve problems involving projectile in physics. And with this, we have come to the end of this class. Hope you learned something interesting. In this video, we are going to look at one of the Newton's laws of motion, which is the second law. Alright, because this law is peculiar because of its relationship between impulse and momentum. Alright, so what is Newton's second law of motion? It states that, which is also known as law of conservation of momentum. Newton's law of motion, second law of motion, states that the rate of change of a momentum of a body is directly proportional to the applied force and takes place in the direction in which the force acts. So mathematically, it can be expressed using F equals change in momentum. Alright, so this is Newton's second law of motion, what he's talking about mathematically. So if you cross multiply it, you're going to have Ft, which is impulse, because impulse is calculated using force times time, equals momentum, mass times change in velocity. Alright, so this is what Newton's law of motion is trying to express. Alright, so let's look at a couple of questions under this law. Use this formula to solve problems on motion. Alright, okay, so look at this question. It says a horizontal force of 15 Newton acts on a body for 4 seconds. The mass is 4 kg. Calculate the change in momentum of the body within this period. Alright, so let's bring out the parameter. We have our mass to be 4 kg. Right, we have our force to be 15 Newton. We have our time t to be 4 seconds, and we asked to calculate the change in momentum. Remember, Newton's law of second law of motion, the rate of change of momentum of a body is directly proportional to applied force. That's force equals change in momentum. Alright, so when it cross multiply, that means impulse is equals mass times change in velocity. Alright, so from this expression we have here, we can decode or deduce that the momentum, change in momentum of this body within this time will be, since we have our force, will be 15 times our time is 4, alright, which is 60 Newton seconds. So this will be the answer to this problem. 6 Newton seconds. Is either I leave it in this unit or 60 momentum kilogram meter per second. So either of the units will work. Alright, so note that we didn't consider the values here because what is here, this equality sign here means that what is here is proportionate to what is here. Alright, so since we have the parameters for what is here, f and t, we just make use of it. 15 times 4 is 60, so 60 is equal to what is here, the change in momentum. Alright, so that will be the answer to this question. Let's solve another problem. Let's wipe this. Okay, so look at this question. It says a body of mass 6 kg moving with speed of 20 meters per second is suddenly hit by another body moving in the same direction, thereby changing the speed of the former body to 50 meters per second. What is the impulse received by the first body? Alright, let's bring out our parameters. We have a mass to be 6 kg. We have initial velocity to be 20 meters per second. We have our final velocity v to be 50 meters per second. And we don't have f is unknown, t is unknown. So we are going to apply this formula under Newton's second law of motion. F equals change in momentum over t. So when it comes multiply, we have ft equals change in momentum. Alright, we have ft. This is our impulse, and this is the momentum. Alright, so from this quick expression we have here, these values we have, we now have f and t, and that means we're going to work, that means ft, which is the impulse, will be change in momentum. We have the mass to be 6 in brackets. Final velocity is 50 minus 20. So when you simplify this, ft, which is the impulse, will be 50 minus 20 is going to give us 30. So therefore, ft, which will be the impulse received by the first body, will be 30 times 60. It will give us 180 Newton second. So impulse is measured in Newton second. It has the same unit with momentum, Newton second. Alright, so this will be the answer to this problem. It's as simple as that, guys. So this is basically how you can solve problems involving Newton's second law of motion, the relationship between momentum and impulse. And with this, we have come to the end of the class. Hope you learned something interesting. In this video, we're going to look at circular motion and simple harmonic motion in physics. Alright, so let's begin with circular motion. Now, circular motion in physics basically is expressing the concept of centripetal force and centripetal acceleration. Alright, so let's begin with centripetal force. Now, centripetal force in physics is simply a force that keeps the body in a center of motion and is calculated using mv squared over r, whereas centripetal acceleration is the acceleration that keeps the velocity of the body in the center of motion and is calculated using v squared over r. Right, so we're going to solve problems on this, so you see how you can apply these formulas to a problem regarding it in physics. Alright, so let's go to simple harmonic motion, SHM, short form. Now, simple harmonic motion in physics simply or basically is the periodic motion of a body so that its acceleration is directed toward the fixed point and is directly proportional to the displacement of the distance from the same fixed point. Right, and basically there are terms used in simple harmonic motion in physics. Examples of simple harmonic motion in physics: we have the child swing, we have the rotation of the earth, we have your heartbeat. Here is an example of a simple harmonic motion. We also have car shock absorber and the rest of them. We also have the pendulum, oscillating pendulum. So anything that can make a to and fro movement can be considered as an example of a simple harmonic motion. Alright, so let's look at the terms used in simple harmonic motion. We have frequency. Alright, frequency. We have period. We have amplitude. We also have angular velocity. Alright, so we're going to look at these basic four terms in simple harmonic motion. Let's begin with frequency. Frequency in simple harmonic motion simply refers to the number of oscillation per time of a body undergoing simple harmonic motion. Frequency is calculated using W over 2 pi, where W is the angular velocity. Alright, it can also be, frequency can also be seen as the inverse of period T. Alright, period, which is the time. Alright, and frequency is measured in hertz. Alright, so that's the unit of frequency in physics. Alright, now let's look at period, which is T. the time. Now, period is the number of time taken for a ball undergoing simple harmonic motion to complete one oscillation, and is calculated using 2 pi over w, or you can say to be the inverse of frequency. That's period equals inverse of frequency. Note again that period can also be calculated using 2 pi square root of length over g, where length and acceleration due to gravity is given in a question. Alright, so this is pi. It can also be calculated using 2 pi square root of m over k, where m is the mass and k is the spring constant, where mass and spring constant are given in the question. Right, so let's wipe some parts of here and look at and explain amplitude and angular velocity. Okay, before then, just note that since its period is measured in seconds, that's the units. Let's wipe this. Okay, so amplitude is the maximum displacement or distance of a body that going simple harmonic motion, and amplitude is talking about distance that is measured what in meter, whereas the angular velocity is simply the angle inclined around a circle per unit time. That means angular velocity w equals theta over time. Alright, or angular velocity can also be calculated using 2 pi f from the one of the formulas for frequency equals w over 2 pi. So when you cross multiply, w will result to 2 pi f. So that's how I got this 2 pi f. Alright, so don't be confused with it. Now note again that the relationship between angular velocity and linear velocity is expressed in this form: v equals to wr, alright, or v equals to wa at maximum. Alright, so when the distance is at maximum, right, this a is amplitude, alright, so at maximum. Now if you want to calculate the acceleration of a simple harmonic motion, is calculated using a acceleration equals minus w square r, where r is radius, or a equals minus w square a, this capital letter A, which is the amplitude at maximum. Alright, so these are basic formulas you need to get used to in simple harmonic motion, and you'll be good to go. Most of them don't need to memorize them, you can just derive them. Alright, so let's wipe this and solve some problems on it before we call it a class. Okay, so let's look at this question. It said the body of mass 20 grams moves in a circular path radius of 10 meters with a constant speed of 4 meters per second. What is the centripetal force? Alright, so before you solve this problem, note that this is very important, that in simple harmonic motion, the oscillation of a simple harmonic motion is said to be damped, D-A-M-P-E, is said to be damped when the amplitude gradually decreases with time. So take note of this. Right, so let's go ahead and solve this problem. So this is centripetal force. The formula will be mv squared over r. Alright, so our mass is 20 grams, our velocity is 4, our radius is 10 meters. Alright, so very important, you convert this gram to kilogram. So to do that, you divide the 20 by 1000. So that's how to convert from gram to kilogram. So we'll be left with 2 divided by 100. We're going to have 0.02 kg. So when you substitute, you're going to have 0.02 times 4 square over 10. When you simplify this, we're going to have 0.02 times 4 square is 16 over 10. Well, so let me punch this with my calculator and get the value. Okay, so the centripetal force will be 0.032 Newton. Alright, so that will be the answer to this question. Now let's solve another problem. Let's wipe this. Okay, so this question says, what is the period of oscillation of mass 40 kg on a spring with constant K 10 Newton per meter? Alright, so we have our parameters, mass to be 40 kg. We have our spring constant to be 10 Newton per meter. I am looking for T. Period is unknown. That means we are going to apply 2 pi square root of m over k. Alright, since we have mass and spring constant, so we're going to have 2 pi square root of mass is 40 is in kg, so no need converting over the spring constant times. When you simplify this, then you have 2 pi square root of 4. Square root of 4 give us 2. So then you have 2 pi times 2. So the answer to this question, if you are leaving it in pi, will be 4 pi seconds. Right, so that would be the answer to this problem. So let's wipe it and solve one more example under simple harmonic motion. Okay, so let's look at this problem. It says if the frequency of 0.75 meter long simple pendulum is 1.5 Hz, the angular frequency on the corresponding reference circle in radar by second is what? Now note that angular frequency or angular velocity is measured in this unit, radar per second. Take note of this. Alright, so let's bring the parameters. We have our frequency to be 1.5 Hz. We have our radius length to be 0.75 meter. Then we are looking for angular frequency. So we still apply the formula for angular velocity to this. Alright, or okay, let me just say, let's use the frequency formula. Frequency equals W over 2 pi. Alright, so this W here also representing angular frequency will be, when you cross multiply, the angular frequency will be 2f pi. So when you substitute, angular frequency will be 2 times the frequency here is 1.5 pi. So to give us, when you simplify it, then we have 3 pi radii per second. Alright, so this will be the angular frequency. So guys, this is basically you can solve problems involving circular motion and simple harmonic motion in physics. And I hope I explained everything easily for you guys. And with this one comes the end of the class. So that's something interesting. In this video, we're going to look at the concept of collision in physics. Alright, so collision is something we see in everyday life. Alright, so when two bodies hit together, collision automatically occurred. Alright, so that's collision whenever two bodies hit together. Okay, so basically there are two types of collision in physics. We have the perfectly elastic collision and perfectly inelastic collision. Alright, now perfectly elastic collision is a type of collision in which both kinetic energy and momentum are conserved, and it can be calculated using m1 u1 plus m2 u2 equals m1 v1 plus m2 v2. Whereas perfectly inelastic collision is a type of collision in which only momentum is conserved. Kinetic energy is not conserved in perfectly inelastic collision. Right, and for perfectly inelastic collision, it can be calculated using in physics using this formula m1 u1 plus m2 u2 equals v in bracket m1 plus m2. Right, so this is the formula used to calculate perfectly inelastic collision. This one is for perfectly elastic collision. Alright, so let's look at some problems on collision calculations in it and apply this formula to them to get whatever we're asked to find. Alright, note that most of your physics questions or most questions for collision usually come from perfectly inelastic collision. Alright, so take note of that. Now let's get some problems and solve. Let's write this. Okay, let's look at this question. It says a block of mass 0.01 kg moves horizontally with a speed of 400 meters per second and embeds itself in a block of mass 0.39 kg that is initially at rest on a frictionless table. Find the final velocity of the bullet and block. So let's get our parameters so that we know the right formula to apply for this problem. Okay, in this question we have our m1 to be 0.01 kg. Alright, we have our u1 to be 400 meters per second. We have our m2 to be 0.39 kg. We have our u2 to be when m2 is 0.39 kg, the velocity is at rest. Alright, initially at rest, that means it will be 0. Okay, so we are looking for v. Now v That means we're going to use this question is under perfectly inelastic collision. So we're going to apply m1 u1 plus m2 u2 equals v in bracket m1 plus m2. So we are looking for the velocity of impact, right? The final velocity v. So when you substitute these values, you're going to have, remember this u is your initial velocity. We have two initial velocities for this question and two masses. Alright, no, now let's impute the value. We're going to have our m1 is, we're going to have 0.01 times u1 is 400, right? Plus m2 is 0.39 times 0, right? Equals v in brackets. We have 0.01, right? Plus 0.39. So when you simplify this, you're going to have, so let me punch this in my calculator. 0.01 times 400 give us 4. Alright, everything here, 0.39 times 0 still give you 0. So we left 4 at the left side of the equation equals v in bracket. So let me punch what is in that bracket. Okay, so when you add what is inside the bracket, you're going to have 0.4. So to make v the solid formula, you divide both sides by 0.4. This will cancel this. Therefore, our v will be 4 divided by 0.4. It will give us 10. So we're going to have the final velocity to be 10 meters per second. So that will be the final velocity. Now let's wipe this and solve another problem. Okay, let's look at this question. It says a revolver of mass 6 kg releases a bullet of mass 0.05 kg at a speed of 200 meters per second. What is the revolver's speed of recoil? Alright, so let's get the parameters. Our u1 will be 0, our m1 will be 6 kg, our u2 will be 200 meters per second, our m2 will be 0.05 kg. Right? Why our u1 is 0? Because when the revolver is released from the bullet is released from the revolver, rather, the bullet initially we have a velocity of 0 before it starts moving at this velocity of 200 meters per second. Alright, so don't be confused with it. So initial velocity will be 0. Okay, so and we are looking for, we ask what is the revolver speed of recoil. Alright, so we're looking for final velocity, which is unknown. That's the velocity is used to return recoil. Alright, so now we're going to apply, this is perfectly inelastic collision. We're going to apply m1 u1 plus m2 u2 equals v in bracket m1 plus m2. So when you substitute, we're going to have our m1 is 690 plus, so m2 is 0.05 times u2 is 200, right, equals v in brackets. So we have 6 plus, right, 0.05 all in brackets. Okay, so when you simplify it, everything I give you 0. So let me multiply 0.05 by 200. Okay, so we're going to have 10 equals v in brackets. So 6 plus 0.05 give us 6.05. So to make v the solid formula, divide both sides by 6.05. 6.05. If we cancel this, so therefore 10 divided by 6.05. Let me punch it. Alright, so our final velocity will be 1.65. if you are leaving it in 2 decimal places, meter per second. Right, so this will be the speed of recoil, the final velocity. So let's wipe and solve one more example, and after you can call it a class. Okay, so let's look at this typical question. It says a rifle fires a bullet of mass 0.01 kg with a velocity of 200 meters per second. Find the recoil velocity if the mass of the rifle is 6 kg. Right, let's get our parameters. In this question, we have our m1 to be 0.01 kg. We have our u1 to be 300 meters per second, and we have our m2 to be 6 kg. Our u2 will be 0, right, because the waveform is not moving. Alright, so we are asked to find the record velocity v. Alright, that means we still apply. This question is under perfectly inelastic collision. Like I told you, most of the questions we see in collision will come from perfectly inelastic collision. Alright, so we're going to final velocity is unknown, so we're going to apply m1 u1 plus m2 u2 equals v in bracket m1 plus m2. So let's substitute the value. We're going to have m1 is 0.01, right, times 300 plus our m2 is 6 times 0 equals v in bracket 6 plus 0.01. So when you simplify this, 0.0 times 200 will give us, we're going to have 3. So 6 times 0 is 0. Everything is, we only have 3 at the left side of the equation because, so when you simplify this, v in bracket 6 plus 0.01 give us 6.01. Alright, so to make v the solid formula, divide both sides by 6.01. This will cancel this. Therefore, our final velocity v will be, let me point this with my calculator. 3 divided 6.01. Okay, so I have it to be 0.49, which is approximately, if we are leaving it to one decimal place, 0.5 meter per second. Alright, this is one. Okay, so this is basically how you can solve problems involving collision in physics. We looked at perfectly elastic collision, perfectly inelastic collision. Alright, so this is it, guys. With this, we have come to the end of the class. Hope you learned something interesting. In this video, we are going to look at the concepts of work, energy, and power in physics. Alright, so let's begin with work. Now, basically in physics, work is defined as a product of force to the distance of a body. That means work equals force times distance. Work can also be calculated using mgh when mass and height are given as parameters and force is not given. Alright. Also note that when force is inclined at an angle theta to the horizontal, then the work done, W, will be calculated using force times distance times cos theta, where theta is the angle. When the force is inclined to an angle horizontally, whereas when the force is inclined to an angle vertically, the work will be calculated using force times distance times sine theta. So take note of this difference. This one is when it's inclined, force is inclined to an angle horizontally, whereas this one is when force is inclined to an angle vertically. Alright, so let's solve a typical problem on this before we go to energy. Let's wipe this. Okay, so let's look at this question. It says a ball is pulled 20 meters along a horizontal plane with a constant force of 10 Newton applied parallel to the plane in the direction of angle 60 degrees to the horizontal. Calculate the work done. Alright, so we have our parameters. We have our force to be 10 Newton. We have our distance to be 20 meters. We have our theta to be 60 degrees. Alright, so to calculate the work done will be force times distance times cos 60 or cos theta. When you substitute, you're going to have work equals, so the force is 10 times 20 times cos 60. Note that we use cos because of the angle is inclined to the horizontal. I think when the angle was inclined to the vertical, we would have used sine, but since it's not vertical, it's horizontal, we make use of cos. Alright, so don't make the mistake of using cos when it's horizontal in place of sine when it's vertical, right? So don't make that unnecessary mistake. So let me point this my calculator. Work will be equals, so I have it to be 100 and work is measured in joule, so to be 100 joules. Alright, so let's wipe this and solve one more problem of work before we go to energy. Okay, so this question says an object of mass 100 kg is released from rest and falls through a distance of 10 meters. What is the work done by the gravity? Alright, so our parameters, we have our mass to be 100 kg. We have our distance, it could be used as, since I'm talking about height, let's use height here to replace distance 10 meter, and we are asked to find work done. Alright, so we're going to use work done will be mgh, mass and acceleration due to gravity. So acceleration due to gravity here is 10 meter per second square. So since the object raised from rest is falling, right? So it fell and falls through a distance of 10 meters. That means it was responding to gravity. It should not be minus 10 meter per second square. And if it was going up, the object was thrown up, it would have been against gravity. This would have been a negative number. Alright, so take note of that. So we're going to have, when you substitute, we're going to have work done will be 100 times acceleration due to gravity, 10 times, then we have the distance, which is the height here, times 10. So when we multiply through, we're going to have the value to be 10,000 joules. And that will be the answer to this question. Okay, so let's wipe this and look at energy. Alright, so what is energy? Energy is simply the ability or capacity to do work. Alright, so energy equals work done. Alright, and work done is calculated using force times distance, right? Now, the difference between work and energy is that energy is a scalar quantity, whereas work is a vector quantity. Now, we have two major types of energy. We have kinetic energy and potential energy. Alright, so kinetic energy is the energy possessed by a body in motion and is calculated using half mv square, whereas potential energy is energy possessed by a body at rest. Alright, and is calculated using mgh. Now, the relationship between kinetic energy and potential energy, half mv square equals to mgh. So this will cancel this. Alright, so we'll be left with v square over 2 equals gh cross multiply. So we have 2gh equals v square. Make v the solid formula. So this will cancel this. Therefore, v velocity will be square root of 2gh. And this is the relationship between kinetic energy and potential energy. So take note of this expression, are very important in this concept of energy. Right, so let's wipe this and solve some problems. Okay, this problem says that means the kinetic energy of a gear of mass 40 kg only with a velocity of 3 meters per second. So our m is 40 kg, our velocity is 3 meters per second. Alright, then for kinetic energy, the formula is half mv square. So when you substitute, when you input the values, you're going to have half mass is 40, this times 40 times 3 square. So when you simplify, you're going to have half times 40 times 3 square is 9. Alright, so when you simplify this the more, you're going to have 360 divided by 2. So this is cancel, you're going to have 180 joules. So energy, the unit of energy is joules, is measured in joules. Alright, so let's wipe this and solve another problem. Okay, so let's look at this question. It says a ball of mass 0.4 kg is dropped from a height 20 meters. Calculate its velocity at the ground. Alright, so let's bring out our parameters. We have our mass to be 0.4 kg. Okay, we have our height to be 20 meters. We are looking for velocity. That means we are going to use the formula for the relationship between potential energy and kinetic energy, which is v equals to square root of 2gh. Alright, so let me show you how we derive it again. Potential energy is mgh and kinetic energy is half mv square. So m will cancel this m, so we cross multiply 2gh equals v square. To make v the solid formula, you square both sides, this will cancel this. Therefore, V will give you this. Alright, so now let's input the values to be V equals square root of 2 times our acceleration due to gravity will be 10 meters per second square, so times 10 times our height is 20. That means we're not going to make use of this mass. Alright, so it's not relevant to this question since this is the formula we are working with. Alright, so let's simplify for the V will be square root of 20 times 10 give us 200, 200 times 2 give us 400, so square root of 400 give us 20, therefore our velocity will be 20 meters per second, and that will be the answer to this question. Alright, so let's wipe this and go to power. Okay, so note that power is a scalar quantity. Let me say it now before we go to power. Power is a scalar quantity, it's not a vector quantity. Alright, so let's wipe this now and go to power. Okay, so power is basically the rate of used up energy. So energy we used up is power with respect to time. Alright, so it's the rate of using up energy. That means power can be calculated using work over time. Alright, so another way you can represent this, it can also be calculated using mgh over time. It can also be calculated using, depending on the parameters you have, force times distance over time. And it can also be calculated using force times velocity. Alright, because this work is force times distance to give you work. That's why I have force times distance here over time. Work can also be calculated using mgh. Alright, so you can also calculate work using mgh. That's why I have mgh here. And this force times velocity, remember this distance over time or displacement over time, depending on the parameter, will give you velocity. So that's why I have velocity here. Alright, so let's look at how power is measured in watts. So let's look at some examples and solve together. Okay, a rocket, let's look at this question. A rocket of mass 40,000 kg propelled by a force of 1,000 newton acquires the speed of 3,000 meters per second. Determine the power expended, that's the power used. Alright, so let's bring out the parameters. We have a mass to be 40,000 kg. We have our velocity to be 3,000 meters per second, and we have our force to be 1,000 newton. Alright, so to determine the power, remember power is work over time. Alright, and since we don't have distance given in this question, because if we break this down, this formula down, it will be force times distance over time. Alright, or mgh over time. Since we don't have distance or height in this expression, and we don't also have time in this expression, yes, we don't have time. That means when you break this down, it can also give us force times velocity. That means this is the one we're going to work with. So power in this case will be force times velocity, which will be, the force here is 1,000 times 3,000. Alright, so when you divide this, you're going to have the power to be 1,000 times 3,000. You're going to have 3 million. So we're going to have 3 million watts. So this will be the answer to this question. So let's write this and solve one more problem on this before I call it a class. Okay, this question says calculate the power of a pump release 500 kg of water through a vertical height of 4 meters in 5 seconds. Assuming okay, G is 10 meters per second square. So the parameters here, we have the mass to be 500 kg. We have the time to be 5 seconds. Alright, so we have the height to be 4 meters, and we are looking for power. Is unknown, so power will be mgh over time. So when you substitute the value, we're going to have it to the mass is 500 times the acceleration due to gravity given here is 10. Alright, times height is 4 over the time is 5. So when you break this down, we're going to have 500 times 10 going to give us 5,000. 5,000 times 4 will give us 20,000 over 5. So when you simplify this, you're going to have the answer to be 20,000 divided by 5 will give us 4,000 watts. Alright, so this will be the answer. So this is basically the concept behind work, energy, and power in physics. And with this, we have come to the end of the class. So let's start interesting. In this video, we're going to look at the basic concepts of wave motion in physics. We're going to look at definition of a wave, the parameter used in wave, basic formulas in wave, and properties of wave. Okay, so let's begin with definition. Now, a wave is simply a disturbance that travels through a medium and transfers energy from one point to another without causing any permanent displacement of the medium itself. Alright, so in physics, we have basically two types of wave motion. We have the electromagnetic waves, we have the mechanical waves. Okay, now let's begin with electromagnetic waves. Now, electromagnetic waves are those waves that don't require a material medium for their production or propagation. A couple of examples: we have radio waves, we have light waves, we have infrared waves, that's heat. Alright, we have X rays, we have gamma rays, we also have ultraviolet rays from the sun. Okay, so these are common examples of electromagnetic waves. Okay, so having done this, let's look at the idea behind mechanical waves. Let's wipe some parts of this, or let's wipe this page. Mechanical waves. Okay, now mechanical waves, these are types of waves that require material medium for their propagation or production. And we have two types of it. We have the transverse wave and we have the longitudinal wave. Okay, now transverse wave is a kind of mechanical wave in which the oscillation of wave is perpendicular to the direction of wave motion, whereas longitudinal wave is a kind of mechanical wave in which the oscillation of wave is parallel to the direction of wave motion. Alright, examples of transverse wave have water wave. Okay, also note that all electromagnetic waves we looked at earlier are classified as transverse waves, which include radio wave, light wave, S waves, ultraviolet waves, and the rest of them. Okay, whereas an example of a longitudinal wave, we have a typical example to be sound wave. Okay, sound wave. We also have wave on a string. Alright, it's an example of a longitudinal wave. Okay, now diagrammatically, let me differentiate between transverse and longitudinal wave. Let me show you how it appears diagrammatically. Let me represent a wave motion. Okay, so this is an example of a transverse wave. Alright, whereas a longitudinal wave, we have a shape like this. Let me see. Alright, so this is an example of a longitudinal wave. Now if you observe, you can see that here we have a compression, whereas here we have an expansion known as rarefaction. Okay, rarefaction. This is F. Alright, now the peak of a wave or the top of a wave is known as a crest, whereas the bottom is known as a trough. Alright, this is H. Okay, whereas the distance between the peak and the midpoint, this distance between the peak and the midpoint here, alright, is known as the amplitude A. Okay, so this is basically the difference between transverse wave and longitudinal wave under mechanical wave. Okay, so let's wipe this now and look at parameters used in wave motion in physics. Let's wipe this. Okay, so let's begin with frequency. Now, frequency is the number of oscillation or cycle completed in 1 second by a particle. Alright, so in wave motion, just like in sympatholic motion, frequency is the reverse or inverse of period time. That frequency is the inverse of time. This can be used to calculate frequency, or this formula can also apply. Frequency can be calculated using W over 2 pi, where W is the angular frequency. Alright, now frequency is measured in hertz. Short form is this. Okay, now the next parameter we have is, let's talk about period, which is the time. Okay, so period in wave motion is the number of time taken for a particle undergoing a wave motion. Alright, so period is measured in seconds, which is time, and period is also the inverse of frequency. The period, which is t, inverse of frequency, or it can be calculated using 2 pi over W. Alright, now let's look at the next parameter. We have the amplitude. Okay, so amplitude is the maximum displacement of a particle undergoing a wave motion and is measured in meters. Okay, now we also have wavelength. Okay, so wavelength is also measured in meters. We also have the velocity, which is the speed of a particle undergoing a wave motion, which is measured in meter per second. Okay, so these are the basic parameters. We have others already, but these are the basic ones. Now let's look at the relationship between velocity, wavelength, and frequency in wave motion. The relationship is very important because most of the calculations we do will revolve around that relationship. So let's wipe this and look at it. Okay, so the relationship between frequency and velocity. Okay, so the relationship between velocity, frequency, and wavelength is represented as velocity equals frequency times wavelength, which is our lambda. Alright, so this is the relationship between velocity, frequency, and wavelengths. This is also called lambda, the wavelength. Alright, so take note of this relationship, very, very important. Okay, having known this, let's look at the properties of wave. Okay, basically there are about 4 characteristics or properties of a wave. The first one, we have the reflection, which is the ability of a wave to turn back when it hits a barrier. We have the refraction, alright, which is this is R, which is the ability of a wave to bend when it hits a barrier. We also have the diffraction, which is the ability of a wave to spread out when it hits a barrier. We have the interference, which is the ability of a wave to superimpose. Alright, so this is basically an introduction to the concept of wave motion in physics. Let's call it a class here. We didn't do any calculation in this video. In my subsequent video on this, we're going to focus on calculations. In this video, we're going to learn how to calculate the frequency, wavelength, and velocity of a wave motion in physics. Okay, so let's begin with these problems I have here and progress from there. Question 1 says, what is the period of a wave of wavelength 8 meter at a speed of 800 meter per second? Okay, so let's note this relationship between frequency, wavelength, and velocity in wave motion. Alright, very important. The relationship between the three parameters is velocity equals frequency times lambda. This lambda is wavelength. Okay, now let's get the parameters for question 1. We have the wavelength, which is our lambda to be 80 meter. Okay, we have the velocity to be 800 meter per second. Alright, so we have to find a period as the time is unknown. Now let's use this formula, this relationship, to get the frequency. So if you substitute these values in the formula, you're going to have 800 equals frequency times 80. This is the same thing as 800 equals 80 frequency. Divide both sides by 80 to make frequency the solid formula. Alright, so this will cancel this, will be left with 10. So that means our frequency is about 10. Now that we have frequency to be 10, to get the period, now in wave motion, time is the inverse of frequency. Alright, so this will be, since the frequency is 10, it's going to give us inverse of 10. This is the answer. This will be the period. It's either you leave it in this fraction, or when you simplify it, 1 over 10 is the same thing as 0.1 seconds. Alright, so this will be the answer. Okay, anywhere we go, either this one or this one. So that's it for the question 1. Let's look at question 2 and solve it together. Let me wipe below. Okay, so the question 2 says the period of a wave is 0.05 seconds. Calculate the wavelength if its speed is 330 meters per second. Okay, so let's get the parameters. We have the period time to be 0.05 seconds. We have the velocity to be 330 meters per second. So we're going to work with this relationship V equals F times wavelength, which is our lambda. Okay, now we don't have frequency, and in wave motion in physics, frequency can be calculated as the inverse of time. So to get the frequency, it will be inverse of the time here is 0.05. So when you simplify it, you're going to have 1 divided 0.05 will give us 20 hands. So let's substitute these values now in this relationship. So when you do it, you get the wavelength. So when you substitute, you're going to have the velocity is 330 equals 20, right, times the wavelength. Okay, so this is something as 330 equals 20 times wavelength. So divide both sides by 20. So 330 divided by 20. Okay, so it's going to give us 16.5 meter, and this will be the answer, 16.5 meter. Let's wipe this now and solve one more example, and after it we can call it a class. Okay, so let's look at this question. It says a wave pulse on a string moves a distance of 8 meters in 0.04 seconds. Determine the velocity of the pulse, B, the frequency of a periodic wave on the spring if its wavelength is 0.5 meters. So let's begin with A part of it. So let's get a parameter, very important. So we have in the question, we have the wavelength, which is lambda to be 8 meters. We have the time period to be 0.04 seconds. We are asked to find the velocity. V is unknown, so we're going to apply this formula. V equals frequency times lambda, that's wavelength, and we all know that frequency is the inverse of time. Alright, so this is going to give us 1 over 0.04. So if you punch on the calculator, it's going to give you 25. Hence, alright, so let's substitute the values in the formula. So we have the hence now to be 25 and the wavelength to be 8. So the velocity will be 25 times 8, which is going to give us 200 meter per second. So that's the velocity. Now let's wipe below and solve the B part of it. Okay, so this time around now we are looking for the frequency, and remember we have got the velocity to be 200 meter per second, and in this question too we have the wavelength, that's the lambda to be 0.5 meter, and we are looking for the frequency is unknown. So we still make use of this formula, P equals frequency times lambda. Okay, now to solve this, we are going to substitute the values. So it's going to give us 200 equals frequency times the lambda, that's 0.5. Okay, so you divide both sides by 0.5. Okay, so frequency will now be 200 divided by 0.5 will give us 400 hence, and that will be the answer. So this basically can solve problems involving wave motion. This is basic calculation of wave motion, how to find frequency, velocity, wavelength, period, using this relationship V equals frequency times wavelength lambda. Okay, so that's it for this class, guys. Hope you learned something interesting on this video response. That's it for this class, guys. Thanks for watching. See you in my next video. In this video, we're going to learn how to solve problems involving sound wave in physics. And after going through this video, you'll be able to solve basic calculations involving sound wave in physics easily. So in short, stay to the end of this video because I'm going to explain some issues here. I'm going to simplify a lot. Okay, having known that, let's begin with these questions I have here and progress from there. Okay, question 1 says a hunter at a distance x from a cliff fires a gun. He hears the echo from the cliff after 2.4 seconds. If the speed of sound in air is 340 meters per second, calculate x. Alright, now let's take note of this formula for calculating sound in air. Alright, sound wave in air. Use the formula velocity. We have it to be v equals 2 times distance over t, where t is our time, our x is our distance. So from this question, let's bring out our parameters. So the question, we have our v to be 340 meters per second, and we have our t to be 2.4 seconds. So we don't have our x, we're looking for distance. So all you have to do now is to impute these parameters in this formula to get your x. So when you do it, you're going to have 340 equals, so we have 2 times x over, okay, our time is 2.4, so it cross multiply. When you do this, you're going to have 340 times 2.4 equals 2x. So when you simplify further, you're going to have, let me clean this side. Okay, so you're going to have 340 times 2.4. Let me punch it. So it's going to give us 816. Okay, equals 2x. So to make x the subject formula, divide both sides by 2. So these two carry this 2 here. So 816 divided by 2. So it's going to give us 408. So since we are looking for x distance, the unit will be meter. Alright, so this will be the answer for question 1. So let's wipe this now, solve for question 2. Very interesting, guys. Okay, question 2 says a sound wave emitted from the bottom of a ship travels at 1,500 meters per second vertically downwards through water to an ocean bed 1,000 meters below. and is reflected upwards, what is the time interval between the instant the sound is emitted and the instant the echo is received? So we're looking for time. Remember, we are still working with this formula. V equals 2 times distance over t. So in this question, let's bring out the parameters. We have our V to be 1500 meter per second, and we have the distance x to be 1000 meter. We now have the time. Alright, so we're looking for time is unknown. So let's impute these parameters in this formula. So when you do it, you're going to have our V is 1500 equals 2 times 1000, alright, over t. Okay, so when you cross multiply, you're going to have 1500 t equals, so 2 times 1000 equals 2000. So to make t the solid formula, divide by both sides by 1500. So this we cancel this, therefore our t will be, this cancel this 0, this 0 cancel this 0, so we'll be left with 20 divided by 15. So what we divide first, we have 5 can divide, 5 divide 20, we have it to be 4 over 5 divide 15, 3. So this will be our answer. Is either you leave it in this form, in fraction, or you break it down. When you break it down further, you're going to have 1.33. Let's leave it at 2 decimal places seconds. Alright, so this will be the answer. Either of it will work. So that's for question. So now let's write below and solve for question 3 before we go to the next question. Okay, so question 3 says, a man standing 99 meters from the foot of a tall cliff claps his hands and hears an echo 0.6 seconds later. Calculate the velocity of sound in air in meter per second. Okay, so we are still working with this basic formula. Okay, we are still working with V equals 2x over t. Alright, so let's bring our parameters from this question. In this question, we have the x distance to be 99 meter, and we have our t time to be 0.6 seconds. So we don't have the v is unknown, looking for v. So let's impute this parameter in this formula. So when you do, you're going to have v equals 2 times 99 over, so we have the time to be 0.6. So when you simplify this, you're going to have, let me punch it in my calculator. Okay, so 2 times 99 will give us 198 over 0.6. Okay, so 198 divides 0.6 is going to give us 330 meter per second, and this will be the velocity of sound in air. Alright, so let's wipe this and solve further questions on sound wave. Let's wipe this page. Okay, so let's look at question 4. I have here question 4 says, calculate the frequency of fundamental of a closed pipe of length 20 cm if the speed of sound waves in air is 240 meters per second. Alright, now note this, guys, very important. For frequency of sound wave in a closed pipe, alright, is calculated using frequency equals velocity over 4 times length of sound wave in a closed pipe. Alright, whereas for frequency of sound wave in an open pipe is calculated using frequency equals velocity over 2 times length of sound wave in the open pipe. Alright, whereas when you want to calculate length of sound wave in a closed pipe, you use this formula: length equals wavelength, now lambda over 4. Whereas in an open pipe, you use this formula: length equals wavelength over 2. Alright, so take note of these basic formulas, alright, for closed pipe and for open pipe. So with this, let's solve question 4. So question 4, let's get our parameters. We have our length to be 20 cm. Now you have to convert this cm to meter, alright, to standard units. So to do that, you divide by 100. So it will be 20 over 100. Alright, so when you divide 20 by 100, you're going to have 0.2 meter. Alright, so let's plug it in this formula. Remember, we have the velocity to be 340 meter per second. Okay, so let's plug it in this formula since we are dealing with a closed pipe. So frequency will be 340 over 4 times 0.2. Okay, so let me punch everything in my calculator and see what it's going to give me. So I have it to be 425 Hz. So that's the unit of frequency, Hz. Okay, so that's for question 4. Now let's wipe this and solve question 5. And after it, you can call it a class. Okay, so for question 5, it says the resonating air column of a tube closed at one end emits its fundamental frequency when the effective length of the tube is 55 cm. Calculate the frequency of vibrating air column if the speed of sound in air is 330 meters per second. Okay, so let's get the parameters. In this question, we have the speed of sound, v, velocity to be 330 meters per second, and we have the length to be 55 cm. So you convert it to meter. To do that, you divide by 100. So when you divide this by 100, it's going to give you 0.55. Alright, so we're going to have 0.55 meter. Okay, so let's impute the parameters in the formula. Remember, this is a closed pipe, so we are still going to work with this formula. So it's going to be frequency. We are looking for frequency. Okay, equals the velocity is what, 330 over, so we have 4 times length is 0.55. So let me punch everything in my calculator and see what it is going to give us. Okay, so it's going to give us 150 Hz. This will be the answer. Alright, so this is basically how you can solve problems involving sound wave in physics. This is basically calculations on sound wave in physics. Hope you learned something interesting from this video. In this video, we're going to learn how to solve problems involving reflection of light in physics. Okay, so we are going to look at basically how to calculate problems involving magnification. We also look at mirror formula and how to apply them to solve problems in reflection of light and the rest of them. So ensure you stay to the very end of this video because you are going to learn a lot, guys. Okay, having known that, let's begin with these magnification questions I have here and progress from there. Okay, so the question 1 I have here says the length of a pinhole camera is 12 cm. It is used to photograph an object 60 cm away from the hole and 80 cm high. Calculate the height of the image and magnification produced. Okay, so to begin with, to calculate magnification of light in physics, this is a formula that is applied. Magnification equals V over U, where V is the image distance, whereas the U is the object distance. Okay, so this is I. Okay, now let's bring out the parameters we have for this question. So in this question we have the image distance to be, so it says the length of a pinhole camera is 12 cm. So we have the image distance to be 12, V to be 12 cm, and we have the object distance U to be, it says it is used to photograph an object 60 cm, so it's 60 cm. Okay, we also have the object height, okay, away from a hole and 80 cm high. Okay, the object height, which is HO, to be 80 cm, and we now have the image height, which is a HI. Okay, so let's get the magnification first. To do that, just substitute the values for V and U respectively. So if it is going to be M magnification, it's going to be M magnification equals V is 12 over 60. So when we divide through 12 divide 60, we're going to have it to be, okay, 0.2. So it's either you leave it as 1 over, we break it down, 1 over 5 or 0.2. That will be the answer. It does not have a unit. Okay, magnification does not have a unit. Okay, so that's it for magnification. Now let's go ahead and find the height of the image. Let me wipe some parts below. Okay, so to calculate the height of the image, this is the formula we're going to apply. That's image height HI over object height HO, okay, equals image distance over object distance. Okay, so we don't have the image height, that's what we're looking for. So let's impute these three parameters we have in this expression. So when there is, you're going to have HI over our HO is 80 equals, so our V is 12 over our U is 60. So cross multiply, going to have 60 HI equals 80 times 12. So this is something as 60 HI equals, so 80 times 12 is going to give us 960. Okay, so divide both sides by 60. So this will cancel this. Therefore, our HI will be 960 divided by 60, which will give us was 16 cm. And this will be the image height. So that's it for question 1. Now let's wipe this and solve for question 2. Very, very interesting. Okay, so question 2 says an object of height 40 cm long is placed 0.8 meter in front of a pinhole camera of length 60 cm. What is the magnification and height of image produced? Okay, so let's bring out our parameters. In this question, we have our HO, that's object height, to be 40 cm. Okay, and we have the object distance U to be 0.8 meter. Now, if you check these parameters for this question 2 are in cm. Alright, so this one that is peculiar, that is a meter, you convert it to cm. Okay, so if you do, you're going to have to convert this from meter to cm. It's going to be 0.8 times 100. So multiply by 100. So if you multiply this, it's going to give you 80 cm. Okay, now our image distance V is, okay, say pinhole camera of length 16 cm. We don't have the image height HI is unknown. So let's begin by finding the magnification. As you all know, magnification is image distance over object distance. So the image distance here is what, 16, okay, over the object distance is what, 80. So when you simplify this, we're going to have 16 into 80 will give us 1 over 5, which is something as 0.2. Okay, there's no unit for it. Now to get the, we have to find the height of image produced, that's the image height. We're going to apply this formula, that's hi over ho equals v over u. So when you substitute the values, we're going to have hi over, our ho is 40 equals, okay, so we have our v to be 16 over, and we have our u to be 80. So when you cross multiply, you're going to have, let me clean this side. Okay, so we're going to have 80 hi equals, okay, 40 times 16, which will give us 640. So to make hi the shortest formula, divide both sides by 80. So this will cancel this. Therefore, our hi will be, this will cancel this 0. So 64 into 8 will give us 8. Alright, so the image height is 8 cm. Okay guys, so this is basically how you can solve this kind of problems involving magnification and finding the height of an image. Okay, so let's wipe this now and look at further problems on reflection of light questions. Okay, so let's wipe everything. Okay guys, so this is question 3 of these problems we are solving. So question 3 says an object is placed between two mirrors. We have entered mirror questions now, which are inclined at an angle of 90 degrees while facing each other. The number of images formed by the two mirrors are, so to get the number of images formed by a mirror, this is the formula you apply. Alright, so this is the formula 360 degrees over n minus 1. Alright, so where n is the angle inclined at the mirror. Okay, so in this question, the angle inclined at the mirror is 90. So you substitute 90 for n below. So if you do it, you're going to have 360 degrees over 90 degrees minus 1. So this will give us 4 minus 1, which will give us 3. So we have 3 number of images formed. Okay, had it been we're having 180 degrees there, it would have been 360 over 180 degrees minus 1 in that order. Okay, so that's it for question 3. Now let's look at question 4. Let me wipe below first before I look at question 4 and 5. Okay, so question 4 says an object is placed 15 cm from the pole of a concave mirror of radius of curvature 20 cm. Calculate the magnification of the image formed. Now I want to say something about concave mirror. I want you to take note of it. Now, a concave mirror has a ray principal focus. Okay, hence the focal length is positive. Alright. Now note again that it forms either ray or virtual image depending on the position of the object. Now, if it forms a ray image, then the object distance, which is our u, and image distance, which is our v, from the mirror are both positive. Alright. If on the other hand the image is virtual, that means the v is negative. Okay. Now, for the situation in which the image distance, that's the v, is positive, together with the object distance, which is our u, being positive as well, then the focal length will also be positive. Okay. Now, for such situation, the mirror formula will be calculated using 1 over f, which is our focal length. F stands for focal length. Okay, equals 1 over u plus 1 over v. Alright. Whereas if the image form is virtual, implying that the image distance v is negative, we're going to have the mirror formula to be 1 over f equals 1 over u minus 1 over v. Alright, so take note of this difference. Okay, very important, guys. All right, so having known this, note one thing that for mirror formula, vocal length can be calculated using F equals the radius of curvature divided by 2. All right, now if you want to get radius of curvature when it's not given and you have vocal length, all you have to do is to times vocal length by 2 and get radius of curvature. But when you are looking for vocal length and you have radius of curvature, divide the radius of curvature by 2 and you get the word vocal length. It's as simple as that, guys. So having known these parameters and this formula, let's go ahead and solve question 4 and 5. And after you can call it a class. So let's write below. Okay, so the question says an object is placed 15 cm, that's question 4, from the pole of a concave mirror of radius of curvature 20 cm. Calculate the magnification of image formed. Okay, now to get the magnification of image formed, we need the image distance and object distance. So in this question, we have the object distance u to be 15 cm, and we don't have the image distance, is unknown, and we are given the radius of curvature to be 20 r to be 20 cm. Now to get a vocal length, it will be radius of curvature divided by 2, so it will give us 20 divided by 2, it will give us for 10 cm. All right, now to get the image distance, we're going to apply this mirror formula. That's 1 over f equals 1 over u plus 1 over v. So when you put the formulas, we're going to have 1 over 10 equals 1 over 15 plus 1 over v. Alright, so to make v the shortest formula, so this 1 over 15 equals over this equality sign, I'll change to negative. Let me wipe this side. Okay, so we're going to have 1 over 10 minus 1 over 15 equals 1 over v. So we find the LCM of the denominator, so it's going to give us 30 v. Alright, so 10 into 30 v will give us 3v. Alright, minus 15 into 30 v will give us 2 v equals v into 30 v give us 30. Alright, so when you do the subtraction, our v, you no longer consider this denominator, so that means our v, which is our image distance, will be 30. Okay, so now that you have gotten the image distance to be 30, to get the magnification, remember we're going to apply, to get magnification, you apply v over u, that image distance over object distance. So this will give us our image distance is 30 over our object distance is 15. So when these two divide each other, the magnification will be what? 2. And that would be the answer to this question. So magnification does not have units. So let's write below now, solve question 5, and after it you can call it a class. Very, very interesting, guys. Hope you're learning a lot. Okay, guys, so question 5. It says an object is placed 20 meters in front of a concave mirror of radius of curvature 30 cm. Calculate the position and nature of image formed. Okay, so to solve this question, let's bring out the parameters. So in this question, the object distance, which is our u, is 20 cm, not meter. Correct it, it's meant to be 20 cm. And put it here. Okay, 20 cm, because the unit has to rhyme with the radius of curvature. So it's typographical error, 20 cm. Correct it, guys. Now 20 cm, and we have the radius of curvature r to be 30 cm. We don't have the image distance, is unknown, and we are asked to calculate the position nature of image formed. Okay, now to calculate the nature of image form and position, we need the vocal length, okay, and the image distance. Vocal length is unknown, so to get vocal length is going to be radius of curvature divided by 2. 30 over 2 will give us what? 15. Now let's use the mirror formula. 1 over f, okay, equals 1 over u plus 1 over v. So let's substitute. It's going to give us 1 over 15 equals 1 over our u is 20 plus 1 over v. So when this crosses over the equality sign, it's going to change to negative. So we're going to have, let me clean this part. Okay, so we are going to have 1 over 15 minus 1 over 20 equals 1 over v. So you get the LCM. So the LCM will give us 60. Okay, so 15 into 60 will give us that 60v. 15 into 60v will give us 4v minus 20 into 60v will give us 3v equals v into 60v will give us 60. Okay, so when you simplify further, 4v minus 3v will give us, so our image distance will be 60 cm. Alright, so this shows us that we have to calculate the image, the position and nature of image form. So this is the position of the image, 60 cm. Alright, so the nature of this image, this is a real image. That's the nature. Had it been we got a negative value, it would have been a virtual image. Virtual image. Alright, so since we have a positive value, this is a real image. When you have a negative value, is a virtual image. Okay, so this is basically how you can solve problems involving reflection of light, revolving around magnification, mirror formulas, and the rest of them. Hope you learned something interesting from this video. In this video, we are going to learn how to solve problems involving lens formula under refraction of light. Okay, we learn how to apply lens formula on questions involving refraction of light, and also learn to calculate problems involving power of lens. So ensure to stay to the very end of this video, because we're going to learn a lot. I'm going to be simplifying a lot of things here. Okay, so having known that, let's go into the details of the video. So let's begin with these questions I have here and progress from there. So question 1 says an object placed 2 cm in front of a converging lens of focal length 10 cm produces a magnified image 8 cm high. Determine A, the position of the image, B, the size of the image. Okay, now note that it's either you call it converging lens or convex lens. The two terms mean the same thing. Okay, so for this question, let's first of all bring out a parameter. So for this question, we have, first of all, let's take note of lens formula. Alright, now note that for a converging lens or a convex lens, the focal length is usually positive. Alright, whereas for a diverging lens or concave lens, the focal length is usually negative. Okay, so in this question, converging lens is involved. That means our focal length will be positive. So the mirror formula will be 1 over f equals 1 over v plus 1 over u, where our f is focal length, our v is image distance, and our u is the object distance. So in this question, we have it says an object placed 2 cm in front of a converging lens. So our u is 2 cm. Okay, whereas our focal length f is 10 cm. We also have, okay, produces a magnified image 8 cm high. So we have our image height hi to be 8 cm. Okay, we have to determine the position of the image and the size of the object. So to begin with, to get the position of the image, we are looking for the image distance. That's the position is unknown. So let's substitute the values we have here for u, object distance, and focal length respectively in this length formula. So you're going to have 1 over our f is 10 equals 1 over v plus 1 over our u is 2. Alright, so what make v the surface formula? So this 1 over 2 will cross over the equality side, change the negative. So we're going to have it to be, let me clean this part. Okay, so it's going to be 1 over 10 minus 1 over 2 equals 1 over v. So you find their LCM. So the LCM will be 10v. Okay, so 10 into 10v will give us v. Alright, minus 2 into 10v will give us 5v equals, so v into 10v will give us 10. So at this juncture, you neglect this denominator. So we're going to have v minus 5v, we're going to have it to be minus 4v equals 10. Okay, so you divide both sides by -4 to make v the subject formula. So this will cancel this. So when 2 cancel this one, I'm going to have it to be 2. When 2 cancel this one, I'm going to have it to 5. So 5 over 2 we give, remember we have negative sign here. So 5 over minus 5 over 2 is the same thing as minus 2.5. Alright, so this will be the image distance v equals minus 2.5. Okay, so let me clean this part. Okay, so we now have our v to be minus 2.5. So this is negative value. That means the position of the image is a position. This image is a virtual image since a negative value. Okay, had it been we got it to be a positive value, it would have been a real image. Okay, now to find the size of the object, we're going to apply this formula for it. We're going to apply hi as image height over object height equals image distance over object distance. So when you substitute the values, it's going to give us, remember we have our image height to be 8 over, so we don't have the object height. The object height is what we're looking for, the size of the object, so is unknown. Let's use x to represent it, equals, okay, so the image distance is down minus 2.5. Well, this time around you're not going to represent the minus in this expression. Okay, the minus there shows that the image is virtual, so we're going to use 2.5 over, then the object distance is 2. Alright, this 2 here. So when you cross multiply, you're going to have, let me write below. Okay, so you're going to have 8 times 2 will give us 16. Okay, because 2.5 times you're going to have 2.5x. Okay, so you divide both sides by 2.5. So it's going to give us 2.5. Okay, so this will cancel this. So we're now left with 16 divided by 2.5. Let me punch it. Okay, so it's going to give us 6.4 cm. That would be the object height. Okay, so that's it for question 1. Let's wipe everything and solve question 2. Okay, so for question 2, it says determine the nature and position of the image of object 2 cm from a diverging length of focal length 10 cm. Okay, so for this question, we have a diverging length. Well, that means our focal length will be negative. So the middle formula will be 1 over minus f equals 1 over u plus 1 over v. Okay, so in this question, we have the image distance. Okay, we don't have the image distance. We have the object distance to be 2 cm. Okay, we have the focal length f to be 10 cm. This is 10. So let's substitute this value in the formula. So when you do it, you're going to have, so 1 over, because of it's a diverging length, we are going to apply the minus sign now. Minus 10, okay, equals 1 over 2 plus 1 over v. So to make v the solid formula, this 1 over 2 cross over the equality sign and it will change to negative. So we're going to have 1 over minus 10, okay, minus 1 over 2 equals 1 over v. Alright, so this is what we're going to have. Now, in mathematics, it's not proper for a negative sign to be at the denominator. So this minus sign under 10 will go up to this one. So this whole expression will now be minus 1 over 10, okay, minus 1 over 2 equals 1 over v. Okay, so you get the LCM. When you get the LCM, you're going to have, let me represent it here. So LCM of 10 to v will give us 10v. So 10 into 10v will give us v. So v times negative 1 give us negative v. Alright, minus 2 into 10v will give us 5v. 5v times 1 will give us 5v equals v into 10v will give us 10. 10 times 1 equals 10. Okay, so at this juncture you're going to have minus, let me clean the up. Okay, so you're going to have minus v minus 5 will give us minus 6v equals 10. To make v the solid formula, we have both side by minus 6. Okay, so our v will be 10 divided by minus 6, so it will give us minus 1.666. Let's leave it at 3 decimal places because we keep having 6. Okay, so we have it to be cm. This will be the image distance. So from this question, the position of the image is this value, and the nature is a virtual image since it's a negative value, so is a virtual image. So that's it for question 2. Let's wipe this now and solve further problems on this so that we can understand it better, and also we can help to solve problems involving power lengths. Okay, let's wipe this. Okay, so let's look at this question 3. So question 3 says an object 1 cm high is placed 18 cm from a converging lens, forms a real image 2 cm high. Calculate the focal length of the lens. Okay, so as usual in this problem, let's bring out the parameters. So we have the object height, that's our HO is 1 cm, and we have the object distance U to be 18 cm. We have the image height, that's 2 cm, image 2 cm high, that's our HI to be 2 cm. Okay, so we don't have the image distance B, is unknown. So to find the focal length, we are going to apply this formula. Since it's converging lens, the focal length will be positive, so the length formula will be 1 over f, the focal length equals 1 over u plus 1 over v. In this expression formula, we don't have our image distance. So we have to get the image distance first before we use this formula to find vocal length. Okay, so to get the image distance, we're going to apply this formula: hi, image height over object height, equals image distance over object distance u, equals, so when you impute the value, you're going to have the image height is 2 over object height is 1, equals the image distance v over object distance u is what, 18. So you cross multiply. When you cross multiply, you're going to have 18 times 2. Therefore, our v will be 36 cm. Okay, so now that we have 36 cm, let's substitute everything in this expression, both u and v. Let me wipe this side. Okay, so we now have our image distance to be 36 cm. So when you put it in the length formula, you're going to have 1 over f equals 1 over our u is 18 plus 1 over 36. So we find the LCM. So LCM give us 36f. So f into 36f, we're going to have it to be 36, because 18 to 36f, we're going to have it to be 2f, okay, plus 36 into 36f, we're going to have it to be f. Okay, so we're going to have 36, okay, equals 32f plus equals 3f. So to get the vocal length, divide both sides by 3. So therefore, our vocal length, 36 divided 3, is going to give us 12 cm. And that will be the vocal length. Okay, now let's solve question 4. Let's write everything here. Okay, so question 4 says determine the vocal length of lens with power plus 5 diopters. Okay, now to get the power of a lens, this is a formula that is applied or that is used to get power of lens. So we have the power of lens P equals 100 over vocal length measured in centimeter cm. Okay, so in this question we have the question 4, we have the power of length to be 5. Okay, equals 100 over f. So to get the vocal length, it cross multiply. So we're going to have 5f equals 100. Divide both sides by 5. So vocal length will be 100 divided by 5 is going to give us 20 cm. Okay, so that's it for the vocal length for question 4. And for question 5, let's solve question 5 this side. So question 5 says determine the power of length of a concave lens with vocal length 25 cm. So we have the vocal length to be 25 cm. But remember, this is a concave lens, and a concave lens or a diverging lens usually has a negative vocal length. Alright, so it's going to be, when you impute or express it in the formula we have here, so you're going to have the power P will be 100 over minus 25, because of the nature of the lens is a diverging lens or a concave lens. So when you simplify for this, will give us the power will be 100 divided by minus 25, going to give us minus 4 diopters. Alright, so this will be the power of this lens. Okay, so that's basically you can solve problems involving lens formula under a fraction of light in physics, and also find the power of lens in light under physics. Hope there's something interesting for this video. Now note that convex lens or converging lens is used to correct someone that has myopia or short-sightedness as a defect, whereas a concave lens or diverging lens is used to correct someone that has hypermetropia or long-sightedness as an eye defect. Okay, so that's it for this slide, guys. Hope you learned something interesting. In this video, we're going to learn how to solve problems involving Snell's law under refraction of light using this practice question we have here. Okay, the question we have here says if the refractive index of air to glass is 1.5, calculate the angle of refraction for which the incident angle is 30 degrees. Okay, now Snell's law is basically the second law of refraction, which states that the ratio of the sine of the angle of incidence to the sine of angle of refraction is constant for a given pair of media. So mathematically, we have it to be the ratio of sine of angle of incidence, the sine of angle of refraction is constant for a given pair of media, where this n is the refractive index. Alright, now for this question, we have the refractive index n to be 1.5. Alright, so we have the incident angle to be sine I to be 30 degrees, and we are asked to find the refraction angle. Okay, so sine R is unknown. Okay, so to get it, all you simply have to do is to substitute these values in this expression. So when you do the basic substitution, you're going to have sine 30 degrees over sine R equals 1.5. So you cross multiply. Let me clean the up. Okay, so we are going to have 1.5 sine R equals sine 30. Okay, so this will be 1.5, this one sine R equals sine 30 will give us 0.5. Okay, so divide both sides by 1.5. Okay, 1.5. So this 1.5 will cancel 1.5 here. So we are left with sine R equals 0.5 divided by 1.5. So if you divide it, you're going to have, okay, so you're going to have 0.333, and the rest of them you keep having 333 punches in the calculator. So at this juncture now, remember we are looking for the value of R, the angle for the refraction. Okay, so to do that now, you divide both sides by sine to get the value of R. So when you divide both sides by sine, so this sine cancel itself. So our R, that's the angle of refraction, will now be sine inverse of 0.333. So if you punch in the calculator, it's going to give 19.45. Let me leave it at 2 decimal places degrees. So this will be the angle of refraction. Now note that, let me show you, let me clean some parts. Note in this question, the refractive index is from air to glass, that's from a less dense medium to a denser medium. Okay, now leaving the question came like this: the refractive index is from glass to air, that's from denser to less dense medium, because glass is denser than air. Okay, so it would have been this calculation. In this case, the refractive index would have been 1 over n. If the formula would have used 1 over n equals sine I over sine R. Alright, but since the refractive index is from air to glass, that's from less dense medium to a denser medium. This is the right formula for it. N equals sine I over sine R. Alright, so take note of this difference, very important. So that's it for Snell's law problem, how to do calculations involving Snell's law under refraction of light. Hope you learned something interesting from this video. In this video, we're going to look at the concept of critical angle and how it causes total internal reflection. Okay, we look at how to do basic calculation involving critical angle. Alright, we also look at the relationship between critical angle and refractive index. Okay, so let's look at this question I have here and solve it together. Okay, so the question says calculate the critical angle for light traveling from glass to air. Alright, we are given the refractive index n to be 1.5, so we have n to be 1.5. Again, it's important you note that critical angle is the incident angle at which the angle of refraction is 90 degrees when light passes from a denser medium to a less dense medium. Thus, it could be from glass to air. Alright, so in this question, our angle of refraction sine R will be 90 degrees. Alright, because critical angle is the incident angle at which the angle of refraction is 90 degrees. Okay, so we are looking for sine C. Okay, so we have the critical angle. So we are going to apply this formula sine C over sine R equals 1 over n. Alright, we are using 1 over n because the light is traveling from glass to air, that from a denser medium to a less dense medium. Alright, okay, so having done this, let's substitute the values. If you substitute, you're going to have sine C over sine 90 degrees, this is 90, equals 1 over 1.5. So you cross multiply, you're going to have 1.5 sine C equals, so sine 90 will still give us 1. Divide both side by 1.5. Please cancel this, so we are left with sine C equal 1.5. So when you break this thing down, you're going to have sine C equals 1 divided by 1.5. You're going to have, okay, you're going to have 0.66666. Let's leave it at 3 decimal places. Okay, so now to get the value of C, you divide both sides by sine. So this side and this, therefore the critical angle will be sine inverse of 0.666, so which will give us, let me punch it. Okay, so I have it to be 41.76 if you are giving it in 2 decimal places degree. Okay, so this will be the critical angle. Alright, now critical angle, when it's exceeded, it causes total internal reflection. Alright, so total internal reflection occurs when the critical angle is exceeded for light traveling from a denser medium to a less dense medium. Okay, so take note of that. Again, note that there are 2 main conditions necessary for total internal reflection to occur. 1, light must travel from denser to less dense medium. 2, the angle of incidence in the denser medium must be greater than the critical angle. Okay, so these are two necessary conditions for total internal reflection to occur. Alright, now the relationship between critical angle and refractive index is that critical, let me wipe some parts and show you. Okay, so the relationship is that critical angle, that's sine C, is the inverse of refractive index, or refractive index is the inverse of critical angle. Okay, so this is the relationship. Critical angle is the inverse of refractive index, or refractive index is the inverse of critical angle. So this is basically how you can attempt or solve problems involving critical angle and use it to determine total internal reflection and also identify the relationship between the two of them. That is for this video. Hope you learned something interesting from the video. In this video, we are going to learn how to solve basic problems involving current, electricity in physics. Right, so let's begin by knowing what current or electricity is in physics. So current is basically the flow of charges with respect to time. So we have current, which is denoted as I, equals flow of charges with respect to time. So this charge, also known as quantity of electricity, is measured in coulombs and the time is measured in seconds. Now the unit of current is ampere, so this is the short form for it. Now the next thing we have to take note of is Ohm's law, the relationship between voltage, current, and resistance. So Ohm's law states that a current passing through a metallic conductor is directly proportional to its voltage or potential difference, provided that temperature is constant. So we have it to be expressed mathematically as voltage equals current times resistance, where the voltage is measured in volts, right? The resistance is measured in ohms. The short form for it is this symbol, alright, and the current is measured in ampere. Okay, now let's take note of the relationship between power, current, and voltage. So the relationship is expressed mathematically as power equals IV, current times voltage. Alright, and let's also take note of the relationship between power, current, and resistance. So the relationship is expressed mathematically as power equals I square R. That is the square of current times resistance. Okay, so take note of these formulas, and before we look at the next thing, let's take note of the formula for power, the basic formula for it, which is power equals the rate of using of energy, which is energy used up with respect to time, and energy is work done, right, which is measured in joules, where the unit of power is watts. Alright, so take note of this formula, this relationship, very important, and this basic formula for power. Alright, so let's wipe this now and look at how to calculate the total resistance or the equivalent resistance in series and in parallel. Alright, let's wipe this. Okay, so resistance in series is connected in a circuit. Let me represent it diagrammatically. Alright, so we have something like this. So these are battery. Okay, so we have something like this. Alright, so this is just an illustration. The diagram may not be perfect, and here we have our ammeter used to measure current. So take note of it. Ammeter is used to measure current. So these are R1, R2, R3. We have the V1, V2, V3. Right, so here you have the voltmeter, which measures potential difference or voltage. Alright, now in physics, another term for potential difference is voltage. So they both mean the same thing. It's either you are saying potential difference or you are saying voltage. They mean the same thing, and voltage is the work done in carrying a unit shaft one point to another in an electric circuit. So this is the positive terminal, this is the negative terminal. Let's say this is the flow of current. So the total resistance in series or equivalent resistance in series is calculated as R equals the sum of the individual resistor R1 plus R2 plus R3. Alright, so this is the total. Whereas for resistor connected in parallel, let me draw the diagram. Alright, so you're going to have something like this. This is the terminal. Okay, so you're going to have something like this. Right, so okay, so pardon my drawing, it might not look perfect, just an illustration. Okay, so you have something like this, and here you have your ammeter. Let me correct that. So this is our ammeter. Okay, so this is the good terminal, this is the negative terminal, and let's say this is the flow of current. Alright, current is flowing in this direction. So we have a R1, we have a R2, we have a R3. So the voltage will be somewhere here, right? So this is the typical illustration of resistance connected in parallel, right? So the equivalent resistor or the total resistance in parallel is calculated using 1 over R equals, that's the sum of the individual reciprocal resistors, right? Over R1 plus 1 over R2 plus 1 over R3. Okay, so take note of this difference. This one is for resistance in series, this one is for resistance in parallel. Alright, so having known these basic things in electricity or in current, electricity, in physics, let's wipe this now, solve some problems and apply each of the formulas so I can understand this better. Okay, so let's look at this question. It says a tungsten is marked 200 volts 40 watts. What is its resistance when it is operated at the correct voltage? So in this question we have the parameters. We have our voltage to be 200 volts, we have our power to be 40 watts. We're looking for resistance, is unknown. Alright, so for us to get resistance, we're going to apply Ohm's law, which is V equals current times resistance. And we don't have current. To get current, we use the formula for power. The relationship between power, current, and voltage to get is going to be power equals current times voltage, that's IV. So the power there is 40 equals I, the voltage there is 200. To make I the same formula, divide both sides by 200. Alright, so point here, 1 point here, 5. So our current will now be 1 over 5, which is something as 0.2 ammeter. So you can now plug it in this formula. So it's going to be the voltage you see remain this. You have 200 equals current is now 0.2 times R. Alright, so to make R the formula, you divide both sides by 0.2. So for R will be 200 divided by 0.2 will give us 1000 ohms, and that will be the answer. Alright, so let's wipe this now, solve another problem. Okay, let's look at this question. It says calculate the energy developed in 10 minutes by the system above. Alright, so let's look at the parameters. This problem, we have the current I to be 1 ampere. Right, so this is the current. Alright, then we also have our voltage to be 10 volts inside this circuit. Alright, and we have the resistance in parallel. So to get the total resistance in parallel is going to be 1 over R equals 1 over 5 plus 1 over 5. Alright, so which is going to give us 2 over 5. Alright, so remember 2 over 5 equals 1 over R. Because multiply, going to have 2R equals 5. To make out the short formula, divide both sides by 2. Therefore, R will be 5 over 2, or when you want to put it in decimal, 5 divided by 2 will give you 2.5. Or 2.5. Alright, ohms. So unit is in ohm. So 5 over 2 or 2.5 ohm. Right, so that's the value of R in this circuit. Alright, then for the energy we are looking for, remember power equals rate of using up energy. Alright, so to get our power can be calculated as power equals IV. Alright, so in this case we have current, we have voltage, so it will be the current is 1 times 10, which will give us was 10 watts. So when you plug it here, I'm going to have 10 equal energy. Let's use X to represent it over the time. In this question is 10 minutes. You convert it to seconds, that's 10 times 60. When you cross multiply everything, the energy, which is S, will be 10 times 10, which is 100, 100 times 60, which is give us 6,000 joule. That will be the answer. As simple as that. Let's wipe this now, solve another problem. Okay, so let's look at this problem. It says calculate the current in the diagram above, neglecting the internal resistance of the cell. Alright, so in this problem we have the voltage to be 4 volts. We have the resistance is in parallel, so the total resistance will be 1 over R equals 1 over 6 plus 1 over 3. Alright, so when you punch it in your calculator, you're going to have 1 over 2. Alright, so remember 1 over 2 equals 1 over R. So to get R, it will be, when you cross multiply, it will be R equals 2. Alright, 2 ohms. Now, we are looking for what? We are looking for our current. So current is unknown. So to get the current, we are going to apply Ohm's law, which is voltage equals current times resistance. So we have the voltage to be 4. Now we have the resistance to be 2. Current is unknown, so we have 2 current. So to make current, the straight formula, we multiply by 2. So therefore, our current will be 2 cancel say 1, 2 cancel for 2. So current will be 2 ampere. So it's as simple as that. Let's wipe this now, solve another problem. Okay, so let's look at this problem. It says an electricity board transmits electrical power of 400 kilowatts through a national wind of 40 kV. Alright, calculate the current transmitted. So in this question, we have our parameters. We have the power to be 400 kilowatts. So you convert this kilowatt to watts. If you do it, you're going to multiply 400 by 1000 to give us 400,000 watts. Then we have the voltage to be 40 kV. To convert it to volts, So you multiply this 40 kV by 1000, it's going to be 40 times 1000, which will give us 40,000. And we're looking for current is unknown. So to get current, we're going to apply the relation between current, voltage, and power. So power equals IV. So which will be 400,000 equals current times the voltage is 40,000. So to get current, divide both side by 40,000. It will cancel. So therefore, current will be, when these cancel each other, we have 10. So current will be 10 ampere. Alright, so let's solve one more question before we call it a class. Let's wipe this. Okay, so let's look at this problem. It says an electric ion draws a current of 5 ampere when connected to a 250 voltage supply. Calculates the energy consumed by the ion if it is used for 10 minutes. Alright, so in this question we have a parameter current to be 5 ampere. We have a voltage to be 250 volts. We have time to be 10 minutes, and we are looking for energy. This is unknown. Alright, remember, to get energy can be gotten from the relationship with power equals energy used up, energy with respect to time. Alright, okay, now to get power, remember again that power is related to current and voltage, mathematically expressed as power equals IV. So to get the power, I have a current and we have a voltage. So power will not be 5 times 250, right? So which is going to give us 1250 watts. Now that we have power, let's plug it here and get energy. So it will be 1250 watts equals energy. Let's replace it with X over the time there is 10 minutes, convert it to seconds, which is 10 times 60. So you multiply the energy. X will be 1250 times 10 times 60. So if you punch it with your calculator, you're going to have 750,000 joule. If you want to leave it in kilojoule, divide this by 1000. If you do it, it will be 750 kilojoule. Alright. Oh, what I would say is 75,000 instead of 750,000. So guys, correct it by adding one more zero to that value. Okay, so guys, this is basically how you can solve problems involving basic current electricity. Alright, we looked at Ohm's law, the relationship between voltage, current, and resistance, and many other things we looked at in the course of this video. So with this, I come to the end of the class. Hope you learned something interesting.